Hello dear students, welcome back to Easy Engineering. In today's class we are going to study about linked list. So as we have discussed earlier, linked list is a linear data structure where the elements are placed sequentially but the memory locations are not sequential. Means here this is the linked list. Elements are called as nodes. So here we are having this node. This is again one more node. Total 3 nodes are present in this list. Now we know that linked list is dynamic data structure. Means we can add number of elements, we can add number of nodes in the data structure. So that's why this is called as a dynamic data structure. But there is again a limitation. If we are not having memory available, then we cannot add the element. Whenever we are going for insertion, in that case we have to check the availability of memory space, then we can go for the insertion. So in linked list, elements are called as nodes. Each node is having two parts. First part is called as information part and the another part is next pointer field, which is having address of next element. So address of next element is stored in the next pointer field of the node. Now as we know that here linked list can have the addresses, like suppose this element, this node is placed at third location. This element is placed at suppose first location. This element is placed at fourth location. It may possible like this. Why? Because this is a linked list. Here the elements are sequential but the memory locations are not sequential. So if we want to show this linked list in memory, how to represent linked list in memory? Simply we have to consider, suppose we are having the elements like A, here I am having the element D and suppose here I am having the element E. Then if I want to show this in memory, I will consider at the location 3, this element is A. So here I will place the element A. Then element B is at first location. So I will place this here. But now there is a link between this node and this node. Now this node is having address of the second node. So this address must be placed in the link field of this node. So here I have to include 1. So it means that now it is pointing to D. Then D is having address of next element which is placed at fourth location. So here is E and its address 4 is placed in the link field of D. And then E is the last element, so that's why here we have to include null pointer, means we have included here 0. So it indicates that this is the last element. So if we consider, now this is the memory representation of linked list. Here you can observe elements are not placed sequentially in memory. These elements we are considering one after other. They are linked but they are not placed sequentially in memory. So here address of the first element is stored in start, means we are having a pointer start which is pointing to the first element. So here it includes the first element's address, first node's address, that is 3, like this way. So here if we are considering any linked list, address of the first node is stored in the start variable. We can consider the start or head which is pointing to the first element. Now in this case, if we want to insert any element, any new node, it is possible. We can insert the node in between, we can insert the node at start, we can insert the node at last. So whenever we are going for insertion, in that case first of all we have to check the availability. So we are having one more linked list which is available list, which is having all the free memory locations. That is called as free pool or available list. So if we consider this memory representation, here second place, third place, these two memory locations are free. So these two memory locations are linked to form a linked list which is free pool. So if there is an available space, then only we can add a new element or add a new node in the present linked list. Now we can have number of free memory locations, then we can add number of elements in linked list. Now just like array, there is a space limited, means initially we are declaring that array with particular size. So if we are declaring that array with the size 5, it means that only 5 elements at max we can include, at max we can insert. But in case of linked list, it is not like that. We can insert 5 elements, 7 elements, 100 elements, 1000 elements if we are having 1000 memory locations. Then we can add number of elements. So here we'll study how to insert a new node in the linked list. So suppose this is our linked list. Now here again I consider this is A, D and E. At the locations, suppose this is 3, 1 and 4 for example. So I'll place here at third location A, then at first location this is B, and at fourth location this is E. And this is the last element A. Here the star indicates 3. So it is pointing to 3, then A is pointing to D, D is pointing to E. So in this way I am having this linked list. Now this is the available list. Now suppose here I am having this available list and aval as a pointer which is pointing to available location. Suppose 6 is the first element, then 7, then 5 and then 2 and then this is the last element. So that's why I have included here 0. So now next to 6 I am having 7, then 5 and then one more we are having, that is 2 and this is the last element. So this is my available linked list. Here this is the linked list with start is equal to 3. Now whenever I am going to add a new element in the linked list, first of all we have to check whether there is available space or not. So if aval is pointing to 0, this aval is a pointer, it's pointing to 0, it means that there is a no available space. So in that case it will display the message overflow and we cannot insert a new node in the linked list. But if aval is not pointing to 0, it is pointing to any other memory location, then it means that that particular memory location is free and we can use that memory location to add a new element in the linked list. So now if I want to add a new element, I can add that new element or I can insert the new element at first position, means at start. We can insert the element at start, we can insert the element in between or we can insert the element at last. So if I want to insert the new element at last, it is quite easy because simply what we have to do, we have to change that pointer to the new address and then information part of that new node is taken as whatever the information we want to insert and then next pointer field is changed to 0. So suppose when I am adding the element over here, so this new element is added over here, this next pointer field is changed to this new element. So now whenever I am adding the new element, this new element is taken from available list. So this element is taken over here. So actually here it is pointing to this node and again here we have included null pointer. Means actually here the new element is taken and that new element is nothing but the element free memory location which is available in available list. So this element is taken here. So again it is pointing to this new location. Now new location means whatever the free location we are having. So here it is pointing to this and this element is taken over here. It means that now this is the last element. So that's why next pointer field of this node is null. And now this aval is pointing to next node of this first node because now aval is pointing to the new node indicating that this node is available for new insertion. So presently now this 4 is the address of element E. Now the new node is having the address 6. So now here we have to make the changes. At 4th location we are having E and here the null pointer. So this should be changed to 6. And then now here at 6th place, whatever the element we want to insert, that we have to write. Suppose I want to insert here T, then here we have assigned this to T and now its next pointer field is changed to 0. And now aval is changed to 7. So at the 7, aval is pointing. So here I have to write this as aval. So this aval is pointing to 7, then it is pointing to 2, it is pointing to 0. In that way we have to consider. So this is insertion at last. Now suppose we want to insert a new node in between. So whenever I want to insert a new node in between, suppose I want to insert in between these two nodes. So this node should point to the new node, means here next pointer field of this node is having address of this, and next pointer field of this new node is having address of this. Again this node is taken from the available list. So actually it is pointing to this, means this is pointing to this new node. And this node is pointing to D, it means that this node is pointing to this next node. And now aval is pointing to next available node. So now here the changes should be A was pointing to this D with the address 1. So now suppose this is the new node T with the address, here is the 6, so we will consider 6. So at 6th place, here we have included T, but A is now pointing to 6. So here we have to make the changes like 6. So here it is pointing to 8. Here it is pointing to 6. And then it is pointing to D with the address 1. So here we consider is pointing to D, and then D is pointing to E with the address 4 as it is. So remaining things will rest of the things will remain as it is. Now here aval is pointing to 7. So here now we'll make the change like aval is pointing to 7. So these are the changes when we want to insert a new node in between. In the same way, whenever we want to add a new node here, if we want to add a new node at start, at that time we have to change the start address to the new address. Again that address is taken from the available list, because we have taken that element from the available list, and then that element, new element, is pointing to the previous first node in the linked list. So accordingly we have to make the changes. This is about insertion in linked list. Now if we want to delete a node from the linked list, we have to consider the same process. Means suppose if we want to delete the element which is present at last. So in that case, initially we were having this as a last node. So after deleting that node is taken in the available list. So reverse process we have carried out. So here it is taken. Suppose this is the memory location 6, which indicates the last node, and aval is pointing to 5 for example. Then after deleting this node, the 6th will come here. The 6th memory location will appear over here. And then this aval is now pointing to 6. It indicates that this node is taken as a first node in the available list, because now this node is deleted, means now this node is available for next insertion. So this is considered as an available node. So that's why it is taken in the available list. So it is taken over here, and then as this node is deleted, now this node will become the last node, and hence we have included null pointer over here. So if we want to delete the last node, these two changes we have to do. Now suppose we want to delete a node which is in between. So here I want to delete this node. So again after deleting this node, we are taking this node as the first node in the available list. So it means that again here this node is taken in that way. It means that now this is pointing to next node, because as this node is deleted, here it is pointing to the next node. This node is taken as a first node over here. Means now Abel is having address of this node and this node is having address of the previous node. So these two changes we have to make. Again, if we want to delete the first node in the linked list, same process we have to carry out. Then it is moved to the available list and now start is pointing to the next node. Rest of the nodes will remain as it is. And then here this node is taken in the available list. So I hope you have understood the concept of insertion and deletion in linked list. In the next class, we'll see the next concept. Till then, do study very well. Bye.